Music is full of math. Most of the time, musical compositions can be interpreted through mathematical models. But today, let's do it the other way around. Let's write a mathematical model to create a song. How can we do that? We can look at the idea of rhythm. Rhythm can be measured in two different ways. It can be measured by tempo, and it can be measured by time signature. Tempo measures how many beats there are per unit time. Time signatures measure how many beats there are in a given measure. A measure is simply a collective group of beats. Most songs have constant time signatures and constant tempos. This song is going to have mathematical models to represent how the tempo and the time signature change. The tempo of this song, or any song, is dependent on time. And time, of course, is a continuous function. Therefore, I'm going to write my tempo as a function of time. Now, I want the tempo to change, but I don't want it to change so dramatically that it can be noticeable. I want a slow rising function, something like ln. However, ln grows kind of quickly when it's closer to 0, so we're going to shift it to the left a little bit. So we're going to add e to the 4, so that once we plug in 0, we're already in the slow rising section of the ln graph. Now, what should the initial value be? Well, a standard beat tempo is 120 beats per minute. Now, let's change this to seconds. 1 minute, there are 60 seconds. So this gives me 2 beats per second. Okay. Now, when I plug in 0, I'm going to get ln of e to the 4, which is just 4. Therefore, if I want this whole expression to equal 2 beats per second when t equals 0, I'm going to put a 0.5 up front. This is going to represent my equation for tempo as a function of time. Unlike time, measures aren't continuous. You can't have half of a measure. You can only have natural numbered measures. So I can't write time signature as a function, but I can write it as a sequence. So my time signature at any given n being the number measure that I'm at is going to be equal to whatever my first time signature is times 1/2 to the n. What does this mean? This means that every subsequent measure is going to have half the number of beats that the previous one had. What this also means is that this is a geometric series if you add all the beats up. And it converges. So we can have a song that is not infinite, but has an infinite number of measures. So let's go ahead and do that. I have my expression for tempo, and I have my expression for time signature. I'm also going to say that the song that we're going to write is 5 minutes long. This is going to help us because I can figure out how many beats there are in a measure. Think about it. If the tempo was a constant 120 beats per minute, 120 beats per minute times 5 minutes is going to give me just beats. So it's not as simple here because the tempo is changing, but I can write my tempo as my time derivative of my beats. Is the rate at which the beats are changing with respect to time. So we're going to have to integrate this function to find the total number of beats that are in a 5-minute song. Now, once we have the total number of beats, I can figure out what my initial time signature has to be. Why? Because the total number of beats has to be the same for this function and this function. So here we have to integrate. Here it's a sequence. We have to add all of them up, and we're going to have an infinite number of measures. So the sum of all of my beats from 0 to infinity has to equal whatever the total number of beats is, whatever the total number of beats are that we're gonna find out by integrating this equation. So I'm just gonna let that equal b. Now, the equation for an infinite geometric series is the first term times 1 minus the common ratio. So that has to be equal to b. Now, a sub 1, we don't know what that is, but we know that the common ratio is 1/2. 1 minus 1/2 is a half. A sub 1 over a half is the same as 2a sub 1. So the total number of beats in my song is going to be equal to twice the number of beats in the first time signature. Now, Nicholas Serrano and Andrew Meadows are going to walk you through the math.
So the equation that we're going to use for beats per unit time is equal to 0.5 ln of t plus e to the fourth. And we're going to have to integrate this in order to find out how many beats our song is going to need. So the lower limit of integration that we're going to use is 0, and the upper limit of integration is just going to be a variable t. So the first way we're going to approach this integration is u sub. So after pulling out 0.5, we're going to set t plus e to the fourth equal to u. Du is then going to be equal to dt. We then know that we're going to have to change the upper and lower limits of integration to be in the form of u because, Geronimals, everything has to match. After this, we're now going to need to use integration by parts. So we're going to set w equal to ln of u and d. So then we're going to set dv equal to du, and v is going to be equal to simply u. So our equation is now 1/2 time of u times ln of u minus the integral of u times 1 over u times du. And the u times 1 over u is going to cancel out, so that's going to leave us with the integral of du. So we are left with 0.5 times u multiplied by the ln of u minus u. And we have to solve this from e to the fourth to t plus e to the fourth. So our song is going to be exactly 5 minutes. So in total, 5 times 60, so we're going to have 300 seconds worth of music. So then we're going to put 300 back into the equation for t, and we're going to solve for the total number of beats that our song is going to have. So eventually we come up with 782, roughly 782 beats. Okay, so for this song, we're going to want each subsequent measure to have 1/2 of the beats of the previous measure. So to find the total number of beats, we take the sum of a series of an unknown starting value of beats, and we are able to determine that the total number of beats is equal to twice what the starting value of the beats is. So earlier we determined that our song should have roughly 782 beats total. But we're going to add a couple to the 782 and bring it up to 784 beats. And we're going to do this because 784 repeatedly divides by 2. And if you remember, our song has half the number of beats in each subsequent measure. So this is going to make our lives easier when we eventually record the song. So we know that the first measure is going to contain half of the total number of beats, so that's going to be 392. And the next measure will contain 196, and the fourth measure will contain 98, and so on.